Hi guys, and welcome back to my adventure game creation series on the third, and I'd like to thank the people who've subscribed to this channel and my amazing Patreon who has made it possible for me to record every day. I am going to be doing some programming today. I hope it isn't going to be too complicated for you guys to follow. I created a cube, an empty game object. I gave it a mesh collider, a mesh filter, and a mesh renderer so you can see what's going on. I need to add in the script. I'm going to call it block. I'm going to give this block the script, and we're going to open up Visual Studio, which always seems to load a different monitor. Right, here we go. We are going to have to define a map of the blocks in this map of the pixels within this block. We need to know how big the block itself is. So public int pixel size. Let's try 1 so that we can make it bigger or smaller once we've worked out the different mathematics behind where the mathematics behind where all of the different faces will have to go. I've created a mesh object. We need to have a list of vector 3s for the vertices. We need a list of ints for the triangles. We need to instantiate the mesh, so we'll just do it here. We need to instantiate the map. So new map equals new int pixel size, pixel size, pixel size. We need a for loop to populate the map. So I'm going to press the double tab to autocomplete. I'm sorry if you can hear someone cutting the lawn in the background, or mowing something, or cutting something down, or whatever. Let's populate the X, Y, Z of this map, and we're going to put a block in it. We need to calculate the mesh because otherwise there's no point of setting it here. We need to know whether the block in the map, the pixel in the map, is transparent. So bool is go. Sorry about that. Is pixel transparent in X, in Y, in Z? If X is greater than equal pixel size, or Y is greater than equal pixel size, or Z is greater than equal pixel size, or X is less than 0, or Y is less than 0, or Z is less than 0, return true, because it's, you know, outside of the cube we're working at the moment. If map x, y, z equals 0, return true, because I'm going to be using 0 for air, or similar. If it was Minecraft, I'd be using 0 for air. That's just the easiest way of doing it. I'm doing it like this now so that I can calculate things later without too much hassle. We need to do the calculate mesh function, otherwise the point of the start function won't be apparent. No, I don't need to make it public, do I? No. Void calculate mesh for X pixel size. No. I don't know how I managed to do that. Y pixel size. Z pixel size. Now this is where it's going to do all of the calculations for the mesh of the object at hand. The reason, the logic behind my madness is that if I do it this way now, I can have thousands and thousands of different types of models within my code without having to calculate the triangles and quads, the triangles, the quads and the cubes within a model of within the model of my game without having to do complicated mathematics in my head, because if I would struggle with it, then the game engine will also. Oh, not also, but if I can't do it in my head, then I won't be able to program it successfully to do so. If is pixel transparent X, Y, Z. To get the front, I'm going to do +1 here. So if that is transparent, or is out of range, that's the important part, we need to have another function, add cube front. Let's do that, but add it in now. X, Y, Z. So it needs 3 values, so we know that now, so we'll just do void add cube front in X, in Y, in Z. We know that we need to add triangles to our mesh. we know we know what x equals x plus even math f dot floor to int transform dot x, because the transform dot x position transform dot position dot x, this could be a float, and it usually is a float. Yeah, it is a float, but I'm flooring it to an int, which will take it to the nearest int to make my maths easier, basically. X, Y, Z. Int offset equals 1, because I'm going to be doing maths based upon a 0 later on, I think. Yeah. Triangles dot add 4 offset plus vertices dot count. Triangles dot add 2 offset dot vertices dot count. Triangles dot add 1 offset dot vertices dot count. Triangles dot add offset vertices dot count. Triangles dot add 3. I hope my maths is right. It's been a very long time since I've done this kind of math in my head. I'm hoping I'm doing it right. We'll find out in a bit, won't we? Triangles dot add Now this is the fun part. Vertices dot add new vector 3 x plus 0.5 f. I want it to be 0.5 f because I want the cube that generates to be in the middle of the area that we're generating. I'm going to be doing this one, this add function, and I'll add in the others off camera. But it's important for me to show you the reason why I'm doing it this way rather than doing I could do a switch function, I could do that, particularly since the only thing that changes is the vertices, so I could in principle do a switch function. There may, if you put in the comment section whether this will have a performance impact, I don't think it will. but it may do. So I'm open to suggestions, obviously. Once I've got the code in place, it should be easy enough to change it. I made a boo-boo. .5 F. The F means float, basically. Otherwise, C# doesn't know what you're talking about. New vector 3 x plus 0.5 f y plus negative 0.5 f z plus 0.5 f, and then the last vertices, which we're only doing a quad, which is 4. X plus negative 0.5 f, y plus 0.5 f, z plus 0.5 f. Save this, and I'm going to go over to Unity so that I know that I'm not doing a big boo-boo, which is very possible knowing me. We're to Unity, and we will click play, see what happens. Nothing happens. Why does nothing happen? Oh, but I'm not. Duh! Oh, I am. Right. So, nothing's happening because I didn't add in any functions to put it into the actual mesh, but I am being a dum-dum. That's what's happened. Right. So, mesh dot vertices equals vertices dot to array. Mesh dot triangles equals triangles dot to array. Mesh dot recalculate bounds. Mesh dot recalculate normals. Mesh dot optimize, and then when you get the component, mesh filter dot mesh equals mesh. Right. let's go back into Unity and hope that my boo-boo there fixes that. I'm sorry about that. That was a big boo-boo on my part. Oh. Right, so we can see that there's a box here, but it only has, it only has one triangle. That's interesting. And not only that, but it only has one triangle from one direction. That's extra interesting. Now, I'm pretty sure. That is interesting. Why is it doing that? So, I think my math was wrong. Yes, my math was wrong. Okay. So, this is the corrected math. I'm going to go back into Unity, click play, and there, perfect quad. Now, because I'm doing it this way, I'm going to face a problem, I think, later on when I set UVs and such for the blocks. That's a problem that I'm going to deal with later, but it is important for me to think about that now. For blocks such as stairs, slabs, and the rest of it, that's not a huge problem, but it is a problem that I need to think about. I'm going to add all of the other functions for the different sides, but I thought it was important to show you the reasoning why I'm doing things. So I'll be back in a moment. And we're back. So I've got all of the functions in place for the different maths. I probably am going to change this so that it does just do the maths for the vertices and not worry about the other bits of code, because it's all the same. It should just be a matter of, probably am going to do that. If is pixel transparent, x, y, z, -1. So that's the back. Add cube back, x, z. If is pixel transparent, x, y plus 1, z, so that's top, add cube top, x, y, z. If is pixel transparent, x, y, negative 1, that's the bottom, add cube, bottom, x, y, z. I know it's a misnomer, me calling them cubes, but it's easier to write in one code for the adding and removing of stuff than it is to call them at pixel and the rest of it. They are pixels, but they all make cubes. I hope that's reasonable. If is pixel transparent, x, negative 1, so that's left, add cube, left, x, y, z. If is pixel transparent, x plus 1, so that's right, x, y, z. Now, I hope this will produce a cube. If not, I'm going to be really angry with myself. So it should produce a cube. So I'm going to hit play. Oh, compile errors. Oh. Right, so apparently I was a dum-dum. I didn't put an extra bracket here. And thank you for that comment on my video that you probably heard. I appreciate that. So we're going to go back into Unity. I'm a dum-dum. I'm going to hit play. And hope that it's a cube. So that's that side, that's that side, that side, and is it from the bottom? Cool, it's on the bottom too. Now, so pixels are going to be, let's call it, 40. That's a reasonable number. Now, if I wanted to shape these blocks, it's very simple to do it now because I can just remove them in the array. If I wanted to make like a slab or a stair or a doorway or a fountain or whatever, I could just add it in using the map, which is pretty cool. Because it's all optimized and I'm doing it very easily, I could make the pixel size huge. So let's set it to something like say 40,000. That's quite a huge cube. I'm not quite sure how big I can go with the pixel size. Out of memory, cool. So that's probably too big. Say 3,000. 4,000 even. I can do math. Nope, still out of memory. But the important thing to know is because it's only generating blocks, because it's this is doing just the this is only going to be doing the side, because it's only going to be doing the cube itself. I'm not worried too much about so this made a cube. I can now resize it relatively up or down or whatever. The problem will be when I get too big. Well, as you saw, the memory ran out. The so I'm going to be doing that. So the next video, I'm going to be doing some models, and I'm going to be using a program called Magical Voxel to show you the different shapes in a 3D editor, which I'm going to be using as like a way of saving like a visual representation of the 3D array, and I will then be using the I'm going to be saving the array of blocks of pixels even, so that the this created this block. I can change the size of the pixels to get more detail or less detail. The size of, so this is only one actual block basically. I did it deliberately like this so that if I got it, you can see there's no faces that I haven't got to remove. I don't know how to show you the wireframe. Wireframe. Right. So this shows me all the blocks in the model that I can remove. But because this is a cube, so I'm going to have to find a way to remove all of the because this is a cube and it's fake drawing that many vertices and that many triangles for the whole cube, because it doesn't know that the neighbour next to it is it knows that the neighbour next to it is solid and it has to draw a face, but it doesn't know that the whole thing is a solid block. That is a problem I have to address in the next couple of episodes, but the reason why I didn't want to do it that way in this episode, in these, like from the get-go, is that the computer doesn't care about I don't want the computer to care about if the block next to it is solid or not. I also wanted it to know about the whole. I just wanted to know about the whole of the block, so that when we add in chunk like a chunk which is going to be lots of these cubes, if the block next to it is a full block, then we're going to do this kind of magical logic. If it's not, we're going to have the cube rendered so that it's a whole cube and not just what you see here. I hope this has been interesting for you guys to follow and watch if you're interested in this kind of programming. I'm going to have to do some culling, which is removing some of these unnecessary triangles, but because I didn't, if this is doing it for say this many, there is a way to remove or combine there is a way to combine all of the different sizes of stuff without too much of a problem. The problem that I'm going to have to face is the mathematics behind doing it this way. Basically. But yeah, this episode is mainly to show you the building of a block. This is just one block, which with all of the different possible cubes that I can have in it, which is a lot. I'm going to be doing an example of the models in the next episode. I won't get to texturing them yet because that's a whole nother issue, which we're going to have to find a manager, a script for. I hope you guys love watching these videos. Can you please like this video, click the little bell, click subscribe if you haven't already, and check out the Patreon page if this is the kind of thing that interests you. I hope that you guys are having an awesome day. It's nice and sunny today. And I hope you guys like this video. This has been Right Escape, and I will see you on Thursday.